It's February 2015, and visiting me today from the University of Chicago is Edwin Kite. Now, Edwin, you're working on Enceladus.
That's correct.
A lot of people on this Moons MOOC are pretty excited about Enceladus.
And they're right to be. It's a very exciting moon. It's one of the best places in the solar system to look for life.
Okay, well, we'll come to the life bit, but what I wanted to ask you to begin with is about the eruption mechanism. I mean, sometimes these plumes are described as geysers. Now, geysers are driven by water turning to steam and expansion of vapour driving stuff out. Are the plumes on Enceladus driven by expansion of vapour, or is it just stuff evaporating away into space?
Well, the first thing that you have to consider when you think about volcanism on Enceladus is this is a very gentle process. If you held your hand out over one of these vents, your hand wouldn't be blown upwards. It's a very gentle process, but the vapor is moving very quickly. It's moving at supersonic speed, so it's a very diffuse jet, a very diffuse curtain of water vapor and entrained ice moving upwards from these tiger stripes, these fissures or vents along the south polar terrain of Enceladus. Now, the ultimate driving mechanism, the deep source, is unknown, but we think that liquid water is involved because of the composition of the plumes. They're very rich in salt, and they're also rich in nanosilica that we think can only be produced at the base of an ocean.
Okay, so that's the source, but what makes it expand to space? Because I've read that the neutral buoyancy level of water down one of its cracks is, say, 3 kilometres below the surface. So what makes it come out and jet into space?
If you expose liquid water to a vacuum, that's a very unstable situation. The water will boil internally, and as it boils, bubbles will break at the surface of the water, lofting liquid water droplets into the vapor as it escapes from the surface. Now, as that liquid water rises, it'll freeze, and so what you get is a mix of water vapor and water ice crystals.
Okay, so it's driven from the surface of the water boiling into vacuum. It's not driven from deeper down in the water column, you think?
We don't know for sure. All we know for certain is what we can see at the surface, which is thermal emission from either side of the tiger stripes, indicating temperatures of at least 200 Kelvin, and what we can sniff, as Cassini flies through the plume, it samples the plume composition, and we make inferences about what's going on deep below from that. But yes, putting the evidence together, the best guess seems to be that there's liquid water at relatively shallow levels within the crust, and that's driving the eruptions.
Okay, thank you. And you sort of answered this by saying you wouldn't feel it if you put your hand into it, but some students have been suggesting, aren't these jets going to sort of blow Enceladus out of its orbit?
It's if you take all the momentum in the jets and extrapolate it over geologic time, you don't get a major nudge. However, it's possible that on some exoplanets this process is operating more strongly, and it's possible that on some planets, cryovolcanism can drive planetary orbital shifts.
That's an interesting thought. And just finally, how sustainable do you think Enceladus's activity is? I mean, you agree it's driven by tidal processes. Can it sustain this mass loss throughout the life of the solar system, this rate of mass loss?
Current understanding says no. There's an upper limit on the power output of Enceladus at steady state that's related to the orbital dynamics of both Enceladus and Mimas, the moon just interior to it. It turns out that in order for Enceladus to maintain its current output over the whole lifetime of the solar system, Mimas would have been destroyed earlier in the solar system's lifetime. And so that suggests that, in fact, since Mimas is still there, Enceladus has not been erupting as strongly as it is now over the whole history of the solar system.
That's great. Edwin, thank you very much.
Pleasure talking to you.